Yeah, so I do need to record it because this is a new section. And I don't know if any of y'all are going and checking out my YouTube channel and looking at my videos. Yeah, but I'm from here on out, every time I cover a new section, I'm going to record it and upload it for you guys, okay? And then if you want individual problems worked out, little short videos, you can request those too. So today it is right triangle trigonometry. We are focusing on right triangles, okay? We're not in the unit circle anymore. The unit circle is behind us. We're moving on. We're talking about right triangle trig. Got it? All right, so let's start with a picture. And I'm hoping that everybody knows that a right triangle means that one of the angles is how many degrees? And we use the little box. The little box says, hey, this one is a right angle. That's 90 degrees. And the other two angles are definitely acute. Correct? What do all three angles have to add up to make? 180, okay? So when you're doing right triangle trig, one of these two acute angles is going to be designated as theta. So in this problem, we're going to designate the bottom angle to be theta. You with me? Now, based on where theta is located, we're going to label these sides with either opposite, adjacent, or hypotenuse. So if this is theta and I go straight across, what side is this? Opposite. And I like to say it this way. Opposite of theta is the opposite side. Got it? Opposite of theta, opposite side. What side is opposite the right angle? Did you notice the order that I'm doing them in? I always do them in this order. I locate theta, that's my opposite. I locate the box, that's my hypotenuse. And then the one that's left over has to be adjacent. Have I lost anybody yet? Okay, that's where I'm going to try to lose you, okay? In order to do right triangle trigonometry, there are only two things you need to know. And I mean formulas, okay? There are only two things you need. You need to know SOHCAHTOA. You need to know SOHCAHTOA. And you need to know Pythagorean theorem. Got it? Now, does everybody know what the freak SOHCAHTOA means? Okay, if you don't, let me go through and explain it, okay? Or maybe y'all can help me explain it. What does the S stand for? Sine theta is, and then what does C stand for? Cosine theta is, and the T, tangent theta is, adjacent over hypotenuse. And do y'all see that, I'm sorry, opposite over adjacent? And do y'all see that SOHCAHTOA tells me how to set up the three basic trig fractions? What if I want secant, cosecant, cotangent? Flip it, flip it, flip it, right? And so that's the chief's retarded cousin that they don't tell you about. That's the one they don't tell you about. What is her name? Cho, Show, what is her name? I'll write it down in a second, okay? So, cosecant is h over O, secant is h over A, cotangent is A over O. SOHCAHTOA. SOHCAHTOA. If you want that one, there it is, okay? So cosecant is h over O, secant is h over A, cotangent is A over O. Nobody ever teaches that though. Because who wants to learn SOHCAHTOA? So we'll erase that. But at least it's been recorded. It's now on the record. All right, so at this point, we should be able to do an example. Let's go to number 9. I'm on page 530 if you need to know that. Page 530, number 9. Now, listen to what the instructions want. It says find the exact value of the 6 trigonometric functions. You're going to have to find all 6 trig fractions. Go ahead, Stuart. Oh, dude. You just worked me out of a job right there, man. I thought I was going to have a question to answer. Okay. I highly recommend that you label your sides first. So what is the 5 side? Opposite. What is the 12 side? Adjacent. And the one we don't know is hypotenuse. Now, do I need to know hypotenuse to get the 6 trig fractions? Yes, I do. How can I find the hypotenuse? Pythagorean theorem. And now do you see why I didn't make it a squared plus b squared equals c squared? It's because you're going to be using O, A, and H, and that's easier. So 5 squared plus 12 squared equals H squared. What is the square root of 5 squared plus 12 squared? Okay, good. 13? Y'all might want to check me. I was just guessing. Oh, it's right? Okay. Everybody see how we get that? Oh, you can do that. 25 and 144.
I see. You did 25 plus 144, which gave you 169, which is the square root. Is 13.
There you go. Clicked, didn't it? There it was. You don't see those off. I love seeing those light bulb moments. You know, your face goes from frown to, oh, I got it. Yeah. Okay, now, can I now find all 6 trig fractions? All right, here we go. Sine theta is O over H, which is 5 over 13. And as soon as I have sine, I might as well get cosecant. Right? Sine and cosecant are reciprocals. What about cosine theta? A over H. And then I might as well get secant theta. And what about tangent of theta? Yeah, O over A. And then I can get cotangent of theta. Tell me that's not easier than what we were just doing in the last chapter. Man. Are y'all ready for the next one? Number 17. Ready? Okay. Here's theta. What's the 1? Here's the right angle. What's square root of 5? And therefore, the one left over must be adjacent. Which one am I missing? Adjacent. You know what it's time for? Pythagorean theorem. So we're going to say O squared plus A squared equals H squared. 1 plus A squared equals 5. 5 minus 1 equals 4. And the square root of 4 is 2. So A must be 2. And now if I know O, A, and H, can I get the 6 trig fractions? Here we go. Sine theta is O over H. And uh-oh, that's an effed up SOB. Y'all remember what effed up SOB stands for? Fractioned up square root on bottom. Yeah. And you can't have an effed up SOB. So we're going to have to rationalize. How's that? Rationalized. Now, what about cosine theta? A over H. Whoops, effed up SOB. And we rationalize. And tangent theta is TOA. TOA. 1 over 2. Everybody good on the first 3? Now let's do the next 3 in reverse. Starting with cotangent. 2. Secant. Now, do y'all see the value in writing it down messed up first? If you leave it messed up, when you go to flip it, it fixes itself. And then what about cosecant? Square root of 5 over 1, which is square root of 5. Man, this is not bad. Not bad at all. Can I teach you one more trick? Okay. Let's play the what if game. What if they wanted to know how many degrees this angle is? Do I have a way to calculate how many degrees that is? Yeah, I can take any one of these first 3 trig functions and move the trig function over, right? And do inverse sine, inverse cosine, or inverse tangent. Which of these 3 would be the easiest to do the inverse of? Yeah, because he's not radical, right? So let's find theta. Let's see if we can find theta, and I want it in degrees. So that means you're going to need to be in degree mode. And let's do inverse tangent of a half. What is that in degrees?
26.5.
Okay, so can we round it to just 27 then? I don't want to mess with decimals. Let's just make it a whole number, okay? Everybody see how we get that? Do you see that that was not bad? Do you think I would get this same answer if I would have done inverse sine of square root of 5 over 5? Do you think? You want to try it? Just to see? Inverse sine of square root of 5 over 5. I wonder if it makes 27. Yeah. Isn't that cool? I can do any of the sine, cosine, tangent, inverse to get the angle. Okay, so now we know that this angle is approximately 27 degrees. Can I now get the other angle in the triangle? 27 plus 90 plus what makes 180? $63. Everybody agree? All the angles have to add up to make 180. Here's a nice trick to know. If this angle is 90, these have to make 90, right? That's a pun. 90, right? Yeah. So if you don't want to even mess with the 90, you could just say 90 minus 27. 90 minus 27 gives you the other one, okay? Do y'all know what two angles that add to make 90 are called? Complementary. What if they had to make 180? Supplementary. Y'all need to know those words, not because it's part of the lesson, just because it makes you a good citizen. Okay? And I've got enough time to do one more problem. How many of y'all are interested in doing a word problem? Yes or no? I'm going to do it anyway. I just want you to feel like you had some input. Number 55. It says find the angle of elevation of the sun. Find the angle of elevation of the sun. At 10 a.m. on April the 26th, 2019, a building 300 feet high cast a shadow 50 feet long. Let's draw a picture. Happy face, sun. Sun ray. Ground. Building. Shadow. Oh, and we hope that the building is straight up and down. So we're going to make that perpendicular. This is not the Leaning Tower of Pizza. This is a straight up and down tower. And now let me reread that and we'll get some numbers on there. It says a building 300 feet high. So we know that that's 300 feet. Cast a shadow 50 feet long. Shadow is 50 feet. What is the angle of elevation of the sun? You're going to have to know, according to how that's worded, where theta goes. So if it says angle of elevation, that means somebody is standing at ground level and looking up to the sun. So where does theta go? By the arrow, right? Okay. I do want to let you know that sometimes it says angle of depression. Angle of depression has nothing to do with a mood you're in. It has to do with the person standing on top of the building and looking down. Angle of depression. You're standing at the top looking. What are y'all laughing at? Yeah, so if there's a guy standing up here on the top and he's depressed, he may jump. Yeah. Now, if he's looking down, then the angle of depression is actually this angle. So you need to know the difference. Angle of elevation is here, looking up. Angle of depression is how much he's looking down. Did you see that that is not even inside the triangle? But if I know how much that angle of depression is, can I get the angle inside the triangle? How much do those two angles make? 90. And they'll be complementary. Okay, but we don't have that. Okay, this guy's not up here anymore. He was depressed and he jumped. Yeah, what are we looking for? What is the angle of elevation of the sun? We're trying to find out how many degrees is that angle. Okay? Well, let's consider what is in the picture. I've got this side over here that's 300. Is that side opposite, adjacent, or hypotenuse? Yeah, if this is theta, then this must be opposite. I've also got the length along the bottom. What is that side? Adjacent. And do you notice that the hypotenuse is not given? And therefore we're not going to use it. So now let's talk to the chief. Let's talk to the chief. What two sides are involved? And look at this. If opposite and adjacent are involved, what trig function do I want to use? Tangent. So we're going to say tangent theta is O over A. Do y'all see how to determine which trig function to use? It's based on which two sides have numbers. What if O and H would have had numbers? What if it were O and H with numbers? Then we'd use sine. What about A and H? Cosine. O and A? And that's why you need to be intimate with the chief. On a platonic level, you need to be intimate with the chief. All right, so let's figure this out. We're going to move the tangent over. And we're going to do inverse tangent of 5 goes into 36 times. Inverse tangent of 6. And I need that rounded to the nearest whole number. Oh, Jasmine, you were looking at that awful mean. Do you have a question?
Yeah, I was thinking that it was 60 for a second, but then it's 60.
But you figured it out? Okay.
I answered my own question.
Where did my pen? I just lost my freaking pen. Oh, there it is. I'm getting so old. Do y'all know how old I am? I just had a birthday, September 29th. Okay, it wasn't that close. It's been a while. Huh? Not even close. No. Add another 25. Yeah. Who said 26? No, 50. Oh, 46. No, I'm 50. I'm over halfway to my death. Yes, I am. Do y'all have any questions so far? Okay, I'm actually going to